Welcome back, everyone. Now, today we are doing another Bgcse past paper review. We are doing physics and we are doing a paper 1, and this was from the year 2020. Now, again, please remember, always write your school number, your candidate number, your surname, and your initials. Also, please remember to read the instructions carefully and also follow all the directives given by the examiner. Now let's start with our first question. And our first question reads that an open can of paint has a mass of 5.25 kg. The empty paint can and lid have a combined mass of 0.83 kilograms. Now the question asks, what is the weight of the paint in the can given that the gravitational field strength acting on it is 10 Newton per kilograms? Now, what we're going to do first here is to kind of analyze this question. Very first thing to do is to look carefully. You'll realize that the entire container, including the paint, is 5.25 kg, but only the can itself and the lid is 0.83 kg. So to find the mass of the paint, the first thing to do is to minus the can and the lid from the entire container. So you're going to say 5.25 minus 0.83, and that will give you 4.42 kg. All right, so that is now the mass of the paint. Now, since we have the mass of the paint, we can find the weight of the paint. And remember that weight is equal to mass times gravity. So therefore, the weight here will be the mass, which is 4.42 multiplied by 10, given that 10 is the gravitational field strength that is acting on the can. And so this will give us 44.2 kg. All right, so that will be now the weight. This will be 44.2 newtons. Okay, so that now is the weight of the paint in the can. And so let's go to our option and see which one is correct. And so option C here is the correct answer. All right, so now let's jump on to the next question. For this question, it said the diagram shows a rectangular metal block of weight 450 newtons, which measures 0.6 meters by 0.3 meters by 0.2 meters. And so here now it said that in its current position, what pressure would it exert on the ground? And so you're looking at the base here, which is this section, this portion is on the ground. Okay, so you want to find the area of this space on the ground. So therefore, to find the area of that space on the ground, what you will do is to multiply 0.3 by 0.6. So the area that is on the ground here, it is 0.3 multiplied by 0.6. All right, and so this will equal to 0.18. Okay, and that is meters square. Now, what we want to find here is to find the pressure. So please remember that pressure is equal to the force over area. Okay, so that's the formula for pressure. So we already know what the force is, which is 450 newtons. And now the area is 0.18. All right, so now let's plug that into our equation and say that 450 divided by 0.18, and that now will be equivalent to 2500 Pascal. Okay, so that now is our answer, and so 2500 Pascal is our answer, and so option B is the correct answer for number 2. All right, now let's jump to question number 3. Now for question number 3, so the diagram shows a simplified drawing of a human forearm while lifting a dumbbells. Now it said which row in the table gives the correct classification of the human arm as a simple machine. And so let's just think about what machines are. First and foremost, let's give you something for you to remember how to classify machines. And this will be FLE, flee. So FLE. And that's what I wanted to use to remember the classes of lever or simple machine. So what this means is what is in the middle. So all of these depending on what is in the middle. So to classify a first class lever, F is the fulcrum. So the fulcrum must be in the middle. If you go into second class lever, then the load should be in the middle. If you go into a third class lever, then the effort should be in the middle. So flee is what should be in the middle to classify the lever. And I keep them in the same order: first, second, third, FLE. Fulcrum in the middle for first class, load in the middle for second class, effort in the middle for third class. So please remember flee. So look at this diagram carefully. You want to figure out what is in the middle. The load is here, the effort is here, and the fulcrum is here. Now, if you notice the effort is in front of the fulcrum, right? So the effort is in the middle. So by flee, we know that if the effort is in the middle, then that is the third class lever. So we know it can only be C or D as the answer, right? And something I need to point out again is that first class and second class levers, they are force multiplier, but third class levers, they are distance multiplier, distance or speed, a matter of fact. And so our option here will be C. It's a distance multiplier and also a third class lever, simply because the effort is in the middle. Okay, so you can remember flee and you'll be good. All right, let's go to our next question, question number 4. All right, and for question number 4 here, let us quickly slide down into this. All right, so the air in the hot balloon is heated by a small flame, allowing it to rise. So the balloon is rising because heat is applied to the air in the balloon. It said which row in the table correctly shows the effect of heating on volume and density of the gas in the balloon. All right, so first and foremost, what you need to remember, right, is that if volume increases, right, because remember what density is. Density is mass over what? Volume. So if you have an increase in volume, right, then you have a decrease in what? Density. So if the volume of the gas increases, right, because once you apply the heat to the gas will increase, and so the volume will increase here, and so the density will decrease. So this will be an option right here. Option B. Okay, apply heat to gases, the volume will increase because the molecules spread out. And once the molecules are spreading out, that means takes up more space. Taking up more space, you have an increase in volume. And because of the formula for density, mass over volume, a greater volume give you a decrease in what? Density. All right, so option B is good. Now question number 5. And for question number 5, it said that 2 soccer players simultaneously kick a soccer ball with forces 75 newtons and 125 newtons in opposite directions as shown in the diagram. Now, observing the diagram, you notice that the forces are going 2 different directions as they mentioned, right? And so what I wanted to think about is that there will be an effective force on the ball, okay? Because remember, forces going in opposite direction, to add them, you can just minus, or you give one a positive value and one a negative value. So what you can do here, we could say the resultant force that is acting on the ball will be 125 newtons minus 75 newtons. And so the resultant force will be 50 newtons. So that is the resultant force acting on the ball. Now they asked us to find here, to find the acceleration. And so let me give you a quick formula to find the acceleration here. So what is the acceleration here? Okay, yeah. All right, so let's give a formula to calculate this. So first and foremost, let's give you this formula. Force is equal to mass times acceleration, right? And so therefore acceleration must be force over mass, okay? Force divided by mass. All right, so now we have our force, which is 50 newtons. And so it'd be 50 newtons as our force divided by the mass, which is given as 0.43, which is in the question right here. So divide by 0.43, and this will equivalent to 116.3, all right, meters per second squared. Okay, so the acceleration for the ball here is 116.3 meters per second squared. So option A will be our correct answer. All right, great. Now let's jump to the next question. And for question number 6, it said an athlete runs a distance of 400 meters once around the track. The time when he passes each 100-meter interval is recorded as shown in the table below. Now, just to point out something right here, right? If the athlete starts at a point at the starting line and ends at the starting line, then there is no displacement, okay? Just to make a point there. If you start somewhere and end the same place, then there is no displacement at all, okay? But there is a distance, so therefore we could calculate speed. All right, so let's go into this first and foremost. Let's figure out what is happening here. All right, so what I want to look at, we want to say the greatest speed. So the greatest speed must equal to the less time, right? Because remember, to calculate speed is distance over time, and you calculate for each 100 meters. Okay, so let's go back to the question again. Let's look at it. It said that the time when he passes each 100-meter interval is recorded as shown in the table. So each time is an extra 100 meters. So what I want to look at carefully, right, is that the first 100 meter, then reach 200 meters, then 300 meters, then 400 meters. So how to look at the timing is, I wanted to think about it in this way. From 0 meter, which is the starting line, to 100 meters, it took 12.5 seconds, okay? Now from the first 100 meter to the second 100 meter, which gives us 200 meter, we're going to find the difference between these two values. And then from the second to the third, we're going to calculate the difference between these two values. And then from the third to the last 100 meter, which is the fourth, we're going to calculate the difference between these values. So what I wanted to look at here as a means of quick calculation, you'll minus 12.5 from 27, and that will give you here, will give us 14.5. So this will be 14.5 seconds that it took to run this 100 meters. Going to the next 100 meters, you'll minus 27 from 40.5, and so here you'll get 13. So 27 from 40.5. Here is 13.5. Okay, that's 13.5. Then moving to the last 100 meters, it will be the 40.5 minus so the 62.5 minus the 40.5. And this here will give us 20 meters. So what I wanted to look at this now real quick, right? To make sure that you're understanding this. All right. So the first thing, matter of fact, this will be 22. Okay, this will be 22 actually. All right, it's a 22 seconds. All right. So what I want to look at here now carefully is this. How to look at the difference. You want to find the lowest possible time, because remember, if speed, let me write this down, if speed is equal to distance over time, all right, and each distance is the same distance, 100 meters all the time, to get the greatest speed, then the time must be the lowest time. And so out of all of this, what we're going to get here, we are going to get A, because that is 12.5 seconds. 12.5 is the lowest time out of all the time so far, okay? All right, great. All right, so here now, let's now jump into the next question, question number 7. And for question number 7, it said the table shows the masses and velocities of 4 vehicles. And so we have the mass, we have the velocity on the right, and it said which of the 4 vehicles has the greatest momentum. Now, how do we calculate momentum again? We need to say mass times what? Velocity. So momentum is equal to mass times velocity. All right. I could actually join the formula here, right? So momentum here, okay, is equal to mass times velocity, okay? Mass times velocity. All right, so if you multiply the mass by the velocity and you're looking for the greatest momentum, you're looking for the values that will give you the highest. And so let's just do some quick calculation. 900 times 25, that is 22,500. 22,500. Okay, so multiply 1,350 by 20. That will give us 27,000. This will be 27,000. To multiply 1,550 by 15, here we'll get 23,250. 23,250. To multiply 2,250 by 0, then you get 0. So there is no momentum here. And looking for the greatest momentum. And so 27,000 is the greatest one. So you leave us here with B as our option. All right, so let's jump into the next question, question number 8. And for question number 8, it says which two graphs correctly depict the motion of an object whose speed is constant. It's looking for constant speed. Now, right off the bat, you can notice something here. Look at the graphs and you'll notice something keen about them. So let's talk about them real quick. All right, so the first one, distance and time. So this is a nice graph. And so as distance increases, time increases. And remember that speed or velocity is distance over time. And so as the increase in distance, increase in time, that means it will give you the same speed. So the speed here is constant. So this one is good. Speed versus time graph. As speed increases, matter of fact, by even say the word speed increases, that means speed can't be constant, right? So this one is not true. As a matter of fact, this graph is for acceleration, right? An increase in speed over time is acceleration, or increase in velocity over time is acceleration. Now for graph D, if you have a constant distance and increase in time, what you'll have is a decrease in speed. So you can use some numbers if you want. Let's say you put 10 right here, right? And you put two different numbers. Let's say you put 2 and you put 4, right? So this is 2, for example, this is 4. Then 2 divided by 10, you'll get 5, right? And so on. So you know that as an increase in time, then the speed will be less. And so this graph is also good. Speed over time, that means speed is constant in this graph regardless of the time. So we're looking for graph 1 and graph 4. So let's look for graph 1 and graph 4. And graph 1 and 4 is in option B. So option B here is correct. All right, let's jump to the next question real quick. It said the diagram below shows a rectangular block made of aluminum. The density of aluminum is 2.7 grams per centimeters cube. Now this is asking you what is the mass of the block. All right, so first we have a density, which is great, right? And so since we have density, and so let me write that formula real quick. Now density is equal to mass over volume. That's what density is, right? Mass over volume. So density is mass over volume, okay? So mass divided by volume, that's density. Okay, but now we want to find mass. So to make mass be the subject of a formula, then we're going to say mass is equivalent to density times volume, okay? All right, I'm just kind of curve it a little bit. All right, so density times volume. And so to calculate this now, we already have our density. So let's find our volume real quick. So our volume here will be 4. So volume is equal to 4 multiplied by 2, which is 8, multiplied by 2, which give us what? 16, right? So it will be 16 centimeters cube. And so now let's find our mass. Remember, mass going to be density times the volume. So our mass now will equal to density, which is 2.7 multiplied by 16. And that will give us 43.2 grams. Okay, so the mass here is 43.2 grams. Let's check to see which answer is that. And that is option D. All right. All right, so let's jump to the next question now real quick. The next question here reads question number 10. You see a ball is dropped vertically from point P to point Q. All right, so now let's look at the ball carefully. So point P to point Q. And they said what energy changes take place as the ball falls from P to Q. Now, firstly, at point P, it is potential energy. All right, and so you have a gravitational potential energy at P. As it's coming down, it starts to move, so they're gaining kinetic energy. And so the ball will lose its potential energy and gain in kinetic energy. And so therefore here it will be option B. A point to note is that halfway down here, like half the distance. So when H is half, just to make a note of that, which is half the height. So when half the height, then potential energy is equal to kinetic energy. So I'm going to type that in one real quick, okay? So at this point, half height, we can say potential energy is equivalent to kinetic energy, okay? All right, they are the same value at that point. At point Q, whatever the potential energy at the top is equal to kinetic energy at the bottom, okay? Just to make a note of that. All right, so just in case you see a question like that, you know how to approach it. Now, question number 11. It said the diagram shows a simplified diagram of a water heater. Now you have a polyurethane foam insulator, and you have a plastic jacket. You have an inlet or outlet connections. And so let's see what they're asking us here. It said, what are the best positions for the heating element and the hot water inlet? So looking for the hot water inlet. All right, so let's look at the concept right here. The heating element, normally, well, it's the best place to put it at the bottom, right? So you put it at the bottom right here. So let's say you put it at the bottom. The heating element will go to the bottom of the container. Now, what is important though? There's a concept that you need to know. Putting it at the bottom is fine. But what is happening in this is also important. So let's talk about that a little bit. Now, as heat is applied here, so let's say this is the heating element here. As heat is applied, then the warmer water or the hot water will rise and the colder water will fall. So to get warm water, it is best to have your outlet on the top and the inlet on the bottom. And so they're asking us for the inlet, okay? And so the inlet should be at the bottom. So as the cool water comes in, it gets warmed by the heating element. And so the warm water will rise naturally, all right, because they have more kinetic energy and they will move and rise to the top. Okay, so let's see which option here best describe what you just explained. So again, the heating element at the bottom and the inlet should be at the what? At the bottom as well. So this is option B. Okay, outlet is at the top, inlet should be at the bottom. Okay, all right, so this is option B for this question here. All right, great. All right. So option B is this question for this question. Let's jump to the next question real quick. All right, so the question number 12 is a diagram shows a ray of light leaving here and entering water. So you're leaving here and entering water. Now, first thing to note, right, is that what you need to remember is that air is optically less dense. So this is optically less dense. And so if this is water, then water is optically more dense. Optically more dense. Just to make a note of that, right? Optically more dense. All right. So what is happening here? A question asks, what change would occur to the ray of light as it enters the water? All right. So one thing you notice that the angle here of refraction will be less compared to what was on the air. So you get the angle of refraction is less than the angle of incident, right? So the angle of incident is greater. Okay, so you have a small angle of refraction. That's one thing that is obvious there. And they said, no, it didn't talk about the angle, but it talked about speed and frequency. So again, if it's going into optically more dense object, then the speed of light or the speed of the light will be slower than what is going in. So there's a decrease in speed. So B will be, speed will decrease. So A will be your option here, okay? So decrease in speed. Optically more dense, so it's denser. The particles of the light will travel through, have a more difficult time to pass through. All right, so number 13 is a performer on stage wears a white and blue dress for a role in the play. Now this question asks, what color will she appear to be wearing when red light falls on her? But let's check what she's wearing again. She's wearing blue and white. Okay, so she's wearing blue and she's wearing white. Now, what I want to point out right here, though, right, that this is her clothes, right? This is clothes, which means clothes contains, clothes contain pigment, not light, okay? Because that will be a misleading thing. Most of us may think, okay, it's two colors of light, but I will show the colors of light combination. But bear in mind that she is wearing a what? Clothes, and the clothes contain what? Pigment. So if red light, it's the blue pigment, then what color you get is black, okay? And a white pigment will be showing the red color of light. So that's something I wanted to note there. So in terms of pigment, red plus blue is black, okay? So red plus blue is black, okay? And this is for pigment, okay? So that's give you a black color. Okay, and that is for pigment, just point it out. So quickly, let me give you the combination for light. And this is for light, I'm going to show you right here now. So for in terms of light, these combinations are very important for you to note. So red plus blue, you will get magenta. So this will give you magenta. Okay, the next one here, red, say red plus green. Okay, so red plus green, what you get as a result is yellow. And let's say now blue plus green. Okay, blue plus green, what you get as a result here is cyan. Okay, all right, so just to make a note of that. So red plus blue in pigment, for pigment, you will get black, but light is different. All right, let's jump to our next question real quick. All right, for question number 14, it said that two metal spares, A and B, all right, on insulated base are in contact with each other. A negatively charged polythene rod is then placed close to spare A as shown in the diagram below. So quick, let's do this real quickly. All right, and so what I want to notice here, first and foremost, just to quickly remind you, is that this is a negatively charged sphere, okay? So that's the first thing to remember, that the sphere there is negatively charged, okay? And so since the sphere is negatively charged, then what you should note is that right here in this sphere A, you'll have positive charge, because remember, positive will attract the negative, okay? So the negative charges will come, and the positive charge will come into sphere A, and then the opposite, and then the next charge, which is negative charge, will go to sphere B, because like charges, they will repel. So the negative charges will repel from the negative rod and go into sphere B, while the oppositely charged particles, which is positive particles, will move towards the negative particles. So opposite do what? Attract, and like charges, they what? Repel. So doing this is what change is induced on sphere A and B, while the charged polythene rod is in position shown. So as long as I keep the rod there, then A will be positive, okay, and B will be what? Negative. So that's for A positive, and that negative, so that is option C. Option C. All right, let's jump on to the next question. For question number 15, it says an LED television has a power rating of 75 watt. It said what will be the cost of operating the television for 12 hours if 1 kilowatt hour of electricity is 20 cents? Now, if it's 20 cents, let's first work out our kilowatt hour, okay? So first and foremost, in this question here, we need to first figure out over kilowatt hour. Okay, and so what we're going to do is to multiply here by 75 multiplied by 12 hours, so that is watt hour. All right, or you could do it in two ways. First, you could convert the 75 watt into kilowatt by dividing by 1,000, or you can just say kilowatt hour, watt hour, and they change that into kilowatt. So what you could do here now is to say this is equal to 900, and so 900 divided by 1,000, because remember you have to convert the watt into kilowatt. Okay, divided by 1,000. Okay, you will get here 0.9, and this is 0.9 kilowatt hours. Okay, so 9 kilowatt hours. All right, so once you have that now, the next thing now, remember that 1 kilowatt hour costs 20 cents. So 20 cents in terms of dollar, you divide it by 100, so it's going to be 0.2. So you're going to say now multiply 0.9 by 0.2, okay, because 20 cents in terms of dollar divided by 100, you get 0.2. So therefore, this will give us $0.18, okay? This is $0.18. All right, so that will be the amount that you pay right here. So this will be option B, okay, option B. All right, great. Now let's jump to our next question right here. Question number 16. Now, question number 16, this is a transformer. It's an ideal transformer, right? Has an input voltage of 120 volts and primary turnings of 600. The transformer produces a secondary voltage of 12 volts, right? By virtue of this, a matter of fact, 120 volts to 12 volts, you know this is a step down transformer, right? That's alone give you an idea what type of transformer it is. So it is a step down transformer. But let's give you the formula to calculate transformer real quick in terms of the ratio, number of turns and voltage. Now, firstly, it asks you what row in the table correctly present the number, all right, of the secondary turnings and the output power. So let's now calculate the output power and also the number of turns. Now, first and foremost, right, let's now calculate. Let's calculate firstly our number of turns, all right, because we need to calculate number of turns. So let's do the formula quickly. And so the formula you want you to remember here is that Vs, which is the secondary voltage, divided by the primary. All right, so Vs over Vp, okay, and those are voltage. Okay, so secondary and primary. So the secondary voltage over the primary voltage is equivalent to the number of turns, which is the secondary turns divided by the primary turns. Okay, so that's the formula to use to calculate. And what we want to find here is our secondary turns. Okay, we want to find the turning on the secondary part. So let's go back to the question for your benefit so you see exactly what's happening here. Because notice here we have the turnings for the primary, we have the voltage for the primary, we have the voltage for the secondary, and they actually ask us to find the secondary turnings. Okay, so notice here the secondary turns. So the secondary turns is NS. So S is for secondary, P is for primary, N is the number of turns, V is the voltage, right? So by virtue, let's make NS be the subject of a formula. So NS being the subject of a formula for this, so NS is equal to Vs primary turns divided by the primary voltage. Okay, so this will be our formula right here. Let me kind of drop this a little bit down so we can move it. So I just want to make this out of the way so at least you could get a better viewing of this. Now let's put it down here. Okay, great. So that now is a formula right there to calculate. And so let's just plug them in quickly. So the secondary turn, which is NS, is equal to the secondary voltage multiplied by the primary turns divided by the primary voltage. So let's plug them in real quick. And you can go back to the question and you see what is the turning is. So there'll be 12 volts as our secondary voltage, which is 12 volts right here, multiplied by the primary turns, which is 600, given us 600. So multiply by 600, all divided by our primary voltage, which is 120. Okay. So again, you'll multiply 12 by 600. So all of this will give you here, it will be 7,000. So 12 by 600 give you 7,200. And you divided that by the 120. And so our answer here will be 60. Okay, so it'll be 60 turns. Now, an easy way to do this, as again, if you notice the ratio between the primary and the secondary is 10. If you divide 120 by 12, you get 10. So the ratio there is 10. So definitely it will be 10 times less. Okay, just to make a note of that. All right, so here now it will be 60 is our answer. So a matter of fact, even without looking at the volt power, we get our answer here. But what you need to remember that the power remains the same across the transformer. So A is our answer there. Okay, for ideal transformer, the power remains the same. Question number 17 is a diagram shows the particles in an atom. Okay, P is a proton, N is for neutron, and E is for electrons. And it said, what is the atomic number of this atom? And the atomic number here is based on the number of protons. So if there are 3 P's, that means the atomic number is the same. And a point to note is that the number of protons, number of electrons, and atomic number, they're all the same. Now if they actually find the mass number for this, how do you find the mass number? Again, is the proton plus the neutron, so this will be 7. Okay, all right, just to point that out real quick. All right, let's jump to question number 18. It said, when only the loudness of a musical note is increased, which property of sound wave will also increase? And so for this question, just think about this real quickly. The loudness depends on what of the wave, and is the amplitude. So once the amplitude increases, then the loudness will also increase. Okay, just to point it out. Just to make a quick notation right here, just for your benefit as well. When you're talking about frequency increase the pitch. Okay, so to increase the pitch, you increase the frequency. So pitch is based upon the frequency. Now speed is dependent on the wavelength and the frequency. So if you increase the frequency, right, for the same wavelength, then you have an increased speed. If you increase the wavelength for the same frequency, then you have an increased speed. Now, what is about wavelength? A wavelength, if you increase wavelength, then the frequency will decrease. Okay, just to point that out. So decreased frequency give you an increase in wavelength. All right, just to make a note. All right, so question number 19. Let's try to move on a little bit quicker. It's a student set up a circuit with a mystery component. As light intensity falling on the mystery component, the mystery component increases, the resistance decreases, and more current flow. So I want to figure out something here now, right? That light is falling onto the mystery component, right? So I want to notice light falling on it. So the mystery component now increases, and the resistance decreases. So more light give a decreased resistance, and you have more current flowing. So when you think about it now carefully, more light, decreased resistance, increased flow of current. And so for this now, what we have here is a light dependent resistor. Okay, a light dependent resistor. So that means it is depending on light. It needs light to work. Now, LED, light emitting diode, a light emitting diode, which is LED, that is just a light bulb, right? And that requires, it only emits light when a current passes through it, okay? When a current passes through it, it emits light. I just make a note of that. And a thermistor is simply a resistant or a resistor depending on heat, on temperature. So the resistance is depending on temperature, okay? A variable resistor is something that you adjust, and you can have those that you can adjust manually, or you can have like variable resistor switches and so on. All right. So variable resistor will change the resistor based on a physical means or by switching. Now, question number 20. It said that the simple electron circuit P and Q are shown, right? So circuit P, circuit Q. You have M, you have two diodes. It said which of the following statement is true? Okay, before we get into the true statement here, let's figure out a few things right here real quick, right? Now what I want to point out here is that on a diode, this flat part here, or the base of a triangle, is a positive part, while this part is a negative part. Just to point that out. Now, once I point it out, there's something else I want to make reference to. The positive part is called the anode, okay? So this is called the anode, all right? And then the negative part is called the cathode. So this is the cathode, okay? So look, we established that. All right, so once we establish that, let's now figure out what is happening here. Now, the first option said the motor in both circuit P and Q are on. Not true, because I'm going to show you something real quick, a matter of fact, because the negative is going towards the positive, is connected to the positive charge of the battery, because this side of the battery is positive. The positive should be on the positive and negative should be on the negative for diode, just to point it out, right? So this here will not allow current to flow. So no current will flow, that means this motor will be off, just to point it out real quick. All right, so once we establish that now, we can go to the next option. So option A is totally wrong. And next for part B, so the motor in P will be on while the motor in Q will be off, and that is correct. Okay, based on what you demonstrated, it is correct. I don't need to even go any further with that, but yes. Let's jump to the next question here. Question number 21. Now, question number 21 reads that a student strokes an iron bar labeled P with a permanent magnet in the direction shown in the diagram below. Now, I want you to notice something here carefully. The south pole is what is being used to strike the bar at the base here, the iron bar, right? Now, I want you to think about this now, okay? Think about this. If south pole is here, then what is trailing the south pole will be the north, okay? So wherever south is traveling to, the north pole will be traveling towards that point. So the north within the iron will be going towards the south at all times. So now let's go into it and see exactly what they're asking us, right? And so here now we said that what are pole 1 and pole 2? So again, remember now in this case here, the north, they'll be traveling towards the south at all times. So if the south is ending here, notice this. Let me put it in real quick. The south will end its journey right here. So every time the south ends its journey and lift away from the iron bar, then the north pole within the bar will be at this end, leaving the south at this end, because the south will not travel behind the south. They repel, right? So moving this direction going forward, the north, they are traveling with the south, but they can't come out the bar magnet, out of the iron bar, so they stays in there at this end, right? And so eventually this end will be north and this end will be what? South. Okay, just to point it out real quick. All right, so let's look for an answer here. So 1 will be south and 2 will be north. And so looking for south and north, and C is the correct answer right here. All right, great. Now question number 22. It's a washing machine has a power rating of 1.2 kilowatt and operates a voltage of 120. It's a which fuse would be most suitable? And so first and foremost, we need to figure out to calculate current. Okay, we need to calculate current. And so we have here, we have our power and we have our voltage. Now there are a number of formulas that you can use to calculate power. To calculate electrical power, there are a number of formulas. So I must give you the basic one. Power is equal to I times V, okay? I times V. That's one formula. there's a next formula here to say P, which is power, is equal to I square, which is current square, times R. All right. Just remember that the 2 there means square. Okay. Or I could put a little upside down. Okay, let's leave it as that. But yeah, just remember that it actually is square. Okay. And so power also can be given as V square, okay, V squared over R, okay. So V squared over R, just to make a note of that. Let me put this in too, so you won't be confused by looking over this. So it is I squared times R. Okay, it is also equal to V squared over R. And power can also be equal to, if you show me this formula, that power is also equal to energy over time, okay, which means electrical energy over time, okay. All right, so those are some formulas that you can use to calculate power. But in terms of what we have, the most suitable formula here, since we have power and we have voltage, to find current, we're going to use the first formula, right? But I just want to demonstrate those formulas for you real quick. So here we want to find current. So current based on this formula now is equal to P over V, okay, which is power over voltage, all right? And so this now equals to power, which is 1.2 kilowatt, but we need to calculate our power in wattage. So therefore it will be 1,200 watt divided by 120 volts. And so here we'll have our 10 amperes. Okay, so 10 amps will be our current that is flowing. But there's something I want to point out in terms of fuse. For you to have a good fuse or a recommended fuse, the fuse must be slightly higher than the current flowing. Why? Because remember, the purpose of our fuse is to break the circuit if excess current is flowing. So if the same amount of current is flowing, right? For example, let me highlight these. If the same amount of current is flowing, right, you do not want the same fuse, because the current will blow that fuse out. If a fuse rate lower than the current flowing, they will blow it as well and the circuit will break. So the only correct answer right here, is just delete that, is D, okay? Because D is slightly higher than the current that is actually flowing. So what that means now, if the current flows over 10, going up to 13 or above, then the circuit will break, okay? All right, so let's jump to the next question now, which is question number 23. All right, so question number 23, it reads now that a young man on a camping expedition shouts and hears the sound of his echo after 5 seconds from a nearby cliff. So the cliff wasn't drawn so properly, but there's a little thing here. So let's call it the cliff, the barrier of the cliff. All right, awesome. Now, what I want to point out, right, that if he's shouting and hearing an echo, that means the sound that he's hearing, just to point this out, travels from him to the cliff and also backwards. That's why they have a 2 arrow right here. So once it hits the wall or the surface of the cliff, it will come back towards him. So in other words, there's a point is so that the sound actually travels what? Twice. That's why you have this 2-headed arrow as well. The sound travels twice, from him to the cliff and from the cliff back to him. And that's why you call an echo, in fact. Okay? So when both sound meet, you will get an echo. Now, so let's do some calculation this really quick. They ask us to find how far, which is distance. We want to find how far is, which means only one of these lines, okay? One line you want to find, not 2 lines, because 2 mean twice the distance. So let's point this out real quick. Firstly is that speed, all right, is equal to distance over time. Okay, so speed is equal to distance over time. But what we want to find is distance though, okay? So we can make a note that distance in terms of formula is equal to V times T, okay? Let's make a note of that. Now, once we establish this, okay, we already have the speed right here and we have the time. Let's go back to the time. The time is 5 seconds, right? So the 5 seconds is took to hear the echo. The speed of a sound here is 340 meters per second. So let's calculate now the distance, right? And so the distance here will be speed, which is 340 meters per second, multiplied by 5, and this multiplied by 5 gives us 1,700 meters. That's the entire distance to the cliff and back. Okay, that's the time it took to hear the echo. So to find the distance of the young man from the cliff, it will be half of that distance, which is 1,700 divided by 2. Okay, and so here we'll have 850. Okay, so 850 meter is the distance from him to the cliff. 1,700 is the entire distance back and forth. Okay, that's the time it took to talk or make the sound and hear it. So the answer here will be C. Okay, so C will be the answer for this one. All right, so let's jump to the next question. Now, question number 24 said the figure below represents a schematic representation of a particular type of wave. And so we have radio wave, we have TV waves, we have microwave, ultraviolet wave, gamma wave, gamma rays, infrared light, and we have X-ray. Now we said which of the following electromagnetic waves are normally used for communication. And so for communication, let's just go through them real quick. Go through each list. For option A, by having gamma, it is wrong. Okay, option B, let's see. Okay, X-ray is not used. X-ray is out of it. And for option C, microwave, radio wave, visible light, yes, that's correct. So C is correct. Let's see what is wrong with D. Ultraviolet rays, okay, so that is wrong. So yep, our answer here has to be C. Okay, great. Now let's look at number 25. And number 25, we're halfway there. All right, I know this is a little bit longer than usual because I'm doing some calculation with you just for you to understand. Okay, so just hold on tight a little bit. All right, so question number 25, it says diagram below shows a water wave moving from shallow to deep water. All right, and it said which row in the table correctly describe what happens as the water moves into the deep. So one thing you want to notice here is that the wavelengths, they are longer compared to in the shallow. And if you have longer wavelengths, it therefore means you have greater speed. Okay, just to point it out. All right, so let's look at the table to see what is happening here. All right, so as we go into the deep, we can say that there's an increase in wavelengths. So we know A and B, they are out. So we have to go to C or D. And so the next thing to look out for there is also if you have an increased wavelength, then you have an increase in what? Speed. The frequency will remain the same. Why frequency remain the same? Because it's coming from the same source, okay? So the wave is being generated from the same source. So the wave, the frequency of generating this, the wave will be the same. So option D will be our correct answer, okay? All right, so let's jump to number 26. It said which row in the table correctly identifies a sound wave, and a sound wave is longitudinal and it produced by what? Vibrations. So this one is straight off the bat B. All right, let's go to 27. And question number 27 is two identical insulating balls suspended on a nylon thread come to rest with the thread making equal angles with the vertical line as shown in the diagram. So they come together, make equal distance apart from this vertical line. And so why these balls are moving away from each other at equal distance, it seems because they're identical one, but why they're repelling or moving away from each other is simply because they have the same charge. Okay, so the balls are oppositely charged. If they're oppositely charged, they will attract. So they are both uncharged. No, they stay in the middle if they were placed in the middle. And C, so the ball both carry the same charge, which is good. Same charges will repel, unlike charges will attract. Okay. Now question number 28. Now for question number 28, it's a diagram below is a ray diagram showing a common eye defect. And this eye defect here, if you notice, the image is in front of the retina. So therefore, you notice is short-sightedness. It said, what is the name of the defect shown and a suitable lens used for this correction? So if the image is forming in front of the retina, you need to spread out these rays some more so they can actually go onto the retina. So you want a lens that will cause the rays to diverge a bit. And so this here will use our concave lens. And so a concave lens will look just like this. All right, so, okay, my drawing not so good, but you'll know the inner part will be thinner and the outer part will be, so the inner part and the middle part of the lens itself will be much thinner. All right, so again, this is short-sightedness. So let's look where they are short-sightedness. Short-sightedness is the same as nearsightedness. And so here again is a concave lens. So definitely option C is the correct answer. All right, let's go to question number 29. And for question number 29, it said that Fleming's right-hand rule can be used to determine the direction of the voltage induced in a straight wire when it is moved in a magnetic field. All right, so based on Fleming's right-hand rule, left-hand rule, or right-hand rule, pretty much indicating something. What I wanted to remember is that the three fingers, right? The thumb for T is thrust. Okay, so it's the thrust. So T is for thrust. So let's make a note of that. Thrust is the same thing as force. Okay, so thrust, same thing as force. All right, and if something is moving to force, then there's motion there as well. But I just want to remember thrust, which is force or motion. Okay, so thumb, thrust. The first finger is the field. First finger, F, field. Okay, first finger, F, which is the field. Okay, just to make a note of that. The middle finger, the center finger, let's call it the center finger, C for current. Okay, so just remember that. Okay, first, the thumb, thrust is a force, okay, which will cause what? Motion. And then the first finger, field, and then the center finger or the middle finger, current. Okay, so we're looking for these now. Let's say it's a what direction are represented by the letter X, Y, and Z. So let's go through and see what is here. So X again, which is the thumb. So that is the thrust or the force. And so X will be the motion of a wire, because force or thrust is the same thing. Y, which is the first finger, which is the field, and then the center finger, which is Z, which is the current. Okay, so therefore C is B, sorry, is our takeaway right here. All right, great. Number 30, it said which symbol represents a source of an electric current in a circuit. All right, and so we have here is a fuse. Fuse is not the source. We have a voltmeter, ammeter. So definitely this is a cell. All right, and so cell will produce the current. So 30 is definitely C. All right, let's go to 31 real quick. Now for question number 31, it said a uniform seesaw is balanced at midpoint when forces 200 Newton and Fx are placed 3 meters and 4 meters respectively from the point. And so what I wanted to notice with this type of lever system or machine or simple machine is that we can talk about something called moment of force. So here this is going in this direction because of that force acting downwards. Okay, and this force here going downwards is going to cause a turning in this way. So here we have what they call a clockwise and anti-clockwise moment. Okay, and so what you need to remember is that the clockwise moment is equal to the anti-clockwise moment. So you need to know that. Okay, that's the law of moment. Okay, all right, so if the clockwise moment is equal to anti-clockwise moment, then from this we can safely say that 200 newtons, okay, multiplied by 3 meters is equivalent to F. Let's just say F and leave the X alone. Okay, it's going to be like a difficult for me to write that in. Let's say F times 4 meters. Okay, so I want to find F. So I want to make F be the subject of a formula here. Okay, that's what I want to find. So F is going to be the subject of a formula. Then F will equal to 200 newtons times 3. Let's say 2 times 3, all divided by 4. Okay, all divided by 4. So therefore, it's equal to 2 times 3. 200 times 3. Let's give you 600. So 600 over 4. Let's say 600 divided by 4, which equivalent to 150 newtons. Okay, so that force will be 150 newtons. So in this case here, our option here is A. Again, this is moment of force. Okay, all right, so let's go to question number 32. It's a heat is applied to a fixed mass of gas at constant pressure as shown in the diagram below. So here we have a fixed mass of gas, all right, and the pressure is constant. So if pressure is constant, we know this is Charles' law. Then that means it is the volume over temperature. But let's see what they're asking us. It said, what happens to the kinetic energy of the particles and volume of the gas? Now, first and foremost, once you apply any form of heat to gas, they will move faster. Okay, so kinetic energy should what? Increase. And since you applied heat to the particles and they spread out, then they will get a larger volume. So here we're looking for increase and increase. So increase in kinetic energy and also increase in what? Volume. So option B is indeed our answer. All right, let's jump on to question number 33. It said, which of the following is a vector quantity? Looking for vector. Remember now, vector has both magnitude and direction. And so volume, mass, and speed are not vector quantities. So velocity is, because velocity deals with displacement, which is a vector quantity. Displacement over time. Now, let's look at question number 34. In question number 34, it said the graph below shows the variation in height with time for a transverse wave. And so let's get into this really quick. It said, what is the amplitude and frequency of the wave? All right, first and foremost, let's find amplitude. Amplitude is easy to find. Amplitude will be the depth of the trough or the height of a crest. So from the midpoint here, which I'm going to circle, I'm going to put this dot right here, all the way down, that is the amplitude. Okay, that's the amplitude. And so from 0 to 2 to 2, that is the amplitude right there. So the amplitude is 2. So I can say A is 2 real quick. The amplitude is 2 centimeters. Okay. All right. Now let's find frequency. How do we find frequency? Now frequency is given as 1 over t, which is 1 over period. Okay. So frequency, let me draw the form of a frequency instead of typing it. They're not going to be the same as I want it. All right, so let's call it frequency. Okay, so frequency is given as 1 over t, 1 over period. Okay. All right. All right, great. So 1 over t. Now, what is t? For this entire wave, a matter of fact, is one complete cycle of a wave. Okay, from this point to this point, they're equal points. Exact equal points, and so you have here it goes down, come back up, and go back to this point. That means one complete cycle. That means one entire wave generated in 4 seconds. So the time to produce this wave is 4 seconds. The time period is 4 seconds. So therefore, frequency will equal to 1 over 4, which is time period or period. And so 1 over 4 is a quarter, which gives us 0.25. All right. And so this is 0.25 hertz. All right, that is our frequency. Let's see our option here. And again, amplitude is 2. And so option A is the correct answer. All right, let's jump on to the next question. Question 35. All right, and so this one said, which path will a stream of alpha particles take as it passes the electric field as shown? So first and foremost, what I want to point out in this question is that alpha particles bring a what? Positive charge. So if alpha particles bring a positive charge, it will deflect towards the negative charge. And so the negative charge here, it is here. So it deflect to this side. So D will be your answer right here. Okay. All right. So great. D is our correct answer. All right, let's jump to the next question. Question number 36. We move a little bit faster now because of these questions. These questions, less calculations. All right, so 36, it said, what effect, if any, would increasing the current have on rotating coil of an electric motor? So if you apply more current, the motor will spin faster. So you have, it rotates quicker. So C will be your answer. Okay, great. All right, moving on a little bit faster. Awesome. 37, it said, which of the following is the freezing point of water? And so what I want to do is a convert back into degrees Celsius, because water freezes at 0 degrees Celsius. And so from Kelvin to degrees Celsius, you're minus 273. So if you're minus 273 to get 0 degrees Celsius, you're going to get C. So option C is our answer. So 273 minus 273 give us 0 degrees Celsius. And water freezes at what? 0 degrees Celsius. A matter of fact, pure water in that, a matter of fact, right? Now, 38. For question number 38, they said, which electric appliance uses an electromagnet? Okay, which uses an electromagnet? All right, so let's jump into it. Electromagnet, a car starter motor. Yep, this is our correct answer right here. Electric iron, no. Electric iron we use things like thermostat and so on. All right, or bimetallic strip. All right, so that's definitely not it. All right, 39. For question number 39, it said the diagram shows a dam at what point will the water pressure be the least pressure? And so remember that water pressure increases with depth. So the further you go down, the greater the pressure. So the least pressure has to be at point what? D. That's the highest point. Higher you are, less pressure. That's why deep diving is dangerous and you can get the bends. Okay, if you go deeper and deeper, the pressure will create on you that could damage your structures in the body, especially eardrum and so on, right? And cause internal bleeding. And so definitely deep sea diving is kind of risky. You have to know the depth that you are and know the danger behind it. All right, so question number 40. Let's go back to that. That's no, okay. All right, so question number 40, it said, which list of energy sources contain only non-renewable energy resources? All right, so non-renewable resource, looking for those. So geothermal is renewable. Geothermal is renewable right here. Solar, wind, they are renewable as well. Hydroelectricity, yes, renewable. And so all the non-renewable will be in option D. So natural gas, oil, nuclear, they are non-renewable. They are very hard to get back. Once they use them, very difficult to reform. Okay, very, very difficult. Take a very, very long time. Now, question number 41, and we're almost there. It says bimetallic strips are commonly used in thermostat to automatically switch off electric appliances if overheating occurs. It says the diagram below shows a bimetallic strip made of brass and iron. All right, and what you need to know is the property of brass and iron to know exactly what is going to happen, right? It says which shape will be the bimetallic strip become when it is heated as shown in the above diagram. It said note, brass expands more than iron when heated. This is a big giveaway. So if brass expand more, you're going to get longer, and so it will bend according to B, because if you look at it, it will bend this way. Brass is the top one is going to be longer. The longer one will be bending on the top. Okay, so a longer distance. And so even if we use, let me show you what I'm talking about. If you look at this point and measure them, okay, you notice from here to here compared to even inside, there is a much longer distance, right? So definitely option B is our correct answer. It'll bend this direction. All right, so let's go to option number 42. And in option number 40, question number 42, let's go back a little bit more, moving a little bit too fast. All right, so yes, question number 42, we say a glass rod requires positive charge after rubbing, it said acquired a positive charge after rubbing it with dry silk. It said, how did the glass rod acquire this positive charge? Now remember now, for you to become positive charge, a very easy thing, you lose electrons because electron is negative. Loss of electrons become positive. Okay, so 42, they're going to be B. 43, the question number 43, it said, which of the following devices utilizes thermionic emissions. So when you talk about thermionic emission, you're talking about emission which involves releasing or emitting electrons when heat is applied. So think about the word therm, which coming from temperature or heat, and ionic coming from charged particles, right? And to become charged mean that you lose or you gain electrons. So electrons are set free, so electrons are emitted once you apply heat to this. Okay, so the thermionic emissions refers to discharging of or releasing of electrons once it is applied. And the only thing that will actually does this is the cathode ray tube. Okay. All right. So question number 44 is an astronaut on the moon can see a spacecraft. It said the astronaut sent a microwave signal, a visible light signal, and a radio signal to the spacecraft. The signal all leave at the same time. It said in which order will the signal arrive at the spacecraft? First and foremost, to make this clear, all of these waves, they are electromagnetic waves. So they are part of the electromagnetic family. And what you need to know about electromagnetic waves is that they all travel at the same what? Speed. So if they're traveling at the same speed, it therefore means that they will be there at the same time. So D is the correct answer. Now question number 45, and we're just like 5 questions away. And it said, which of the following list nuclear radiation in order of increasing penetrative ability? And so it is given as in terms of alpha, beta, gamma, because alpha is the least and then gamma will be the most. So alpha, beta, gamma. So option C will be our answer. Okay, so remember the order: alpha, beta, gamma, alpha, beta, gamma. Okay. All right, so you can think about A, B, and Y. A, B, Y. That's the same order. Okay, alpha, beta, gamma. Now 46. Now 46 here, it reads now, it said the carbon in the body of an animal contains some radioactive carbon-14. At the time when any animals die, it emits about 32 beta particles per minute per gram. Is that some animal remains were some animals remains were discovered, and it was found that 4 beta particles are emitted per minute per gram of carbon. So what I want to look in these remains now, right? Again, we have 32 beta particles per gram being emitted. That's what they started out with. At the point of discovery, it was 4 beta. So the point of death, 32 beta. Point of discovery remains 4 beta particles. So what I want to look at here now is that the half-life for carbon-14 is 6,000 years. So what they want to do now, what they asked us to calculate, they said, that's what they asked us to calculate here. They said, if the half-life is at how old, okay, are the remains. So we want to find out how old are the remains for this animal. So let's now work this out. First thing, let's put some numbers here. First thing is start off 32 and it ends at 4, right? So let's do this real quick. So if you start off 32, right, you stop at 4. To break this in half, you go to 16, right? So that's the first half-life. To break 16 to the next half-life, you go to 8. And then you break 8 to the next half-life, you go to 4. So the fourth half-life, this is when you stop. Again, the next half-life will be 2 and then go to 1 and so on, right? Each and divide by a half. Now for the first half-life, it is 600, right? So let's think about this. First half-life, 600. So there are 2 ways you could work this out real quick. So 600 here. The next half-life is from 16 to 8. So the next 600 again. For every half-life, it is 6,000. 6,000. I say 600. 6,000 years. The third half-life again is another 6,000. So 6,000. And so here 666, that will be 18,000. And next we could do it like this. You say 1 half-life, 2 half-life, 3 half-life. So from 32 to 16, 1 half-life. 16 to 8, another half-life. Which is 2 half-lives. From 8 to 4, 3 half-lives. So if each half-life is 6,000, then you're simply going to say 6,000 multiplied by 3 or add all of these together. With the 6,000 plus 6,000 plus 6,000, that gives us 18,000 years. So 46 is C. Okay. All right. So either multiply the number of half-life by the value of each half-life, or just work it out as I work it on the right. Now 47. It says, which of the following particles are found in the nucleus of an atom? The nucleus of an atom contains two particles, which are the proton and the neutron. So 47 here will be C. Now for 48, it asks that, or let's go back to 47 a bit. I want to just point out this. Electrons are found on the shell, so electrons are not in the nucleus. So to make that clear, right? And so the nucleus is positively charged because they have a neutral charge, which is neutron, and also positive charge, which is protons. So proton and neutron give a positive charge. Just to point that out real quick. Now, 48, it says two atoms of neon are shown below. So you have neon 20 on top and 10 at the bottom, neon 22 and 10 at the bottom. Now, remember what these two numbers are. The bigger number is always the mass number. The smaller number is always the proton number. Okay? So which statement is true? Both have the same mass number. Not true, because one is 20, one is 22. Both have the same number of protons. Yes, because 10 is the number of proton, which is the same thing as the atomic number. So 48 is B. Now 49, it's a radioactive decay can be represented as shown. And so here you have first element here, which is uranium. All right, and so the fact that you have 2, 3, 3, and 92, and then the end product here is 2, 2, 9, and 90. Now, what you need to note is that the sum of these numbers here, right, must equal to what is coming from the first part. So the product must equal to the reactant, right? And so the missing numbers here, what you can do is to minus 229 from 233. And what you get here is 4. So you can put 4 right here. Okay. All right. And so the mass numbers must be equal. The mass number in the reactant must equal to the mass number of the product. Always remember that. And so what you can go ahead and minus 90 from 92, you get 2. So it's a what does X represent? And so to find this out, you need to remember what is 4 mass number, this 2 mass number, that's an alpha particle. So this will be our alpha particle right here. Okay. So 49 is C. That is our alpha particle. 4 mass number and a mass number and a proton number of 2. Okay. All right. So last question here is what device converts sound energy into electrical energy? And what I'm using right now is a microphone. We talk into it and it converts our voice by vibrating the diaphragm, and a number of mechanisms take place inside of the microphone. Then we get electrical current. And so we can hear ourselves. And so at this point, we are finished. And again, thank you for being here for another review. See you soon with more reviews. Take care for now.